Hello, everybody, and welcome to today's presentation, Managing SQL Queries and Scripts in Complex Data Environments, brought to you by IDERA. I'd like to introduce you to our presenter, Lisa Waugh. Lisa is a Senior Product Manager at IDERA Software for the AQUA Data Studio Database IDE tool. She has over 15 years in database industry experience, including speaking engagements and presentations on database tools and technologies, and enjoys defining the direction for database development solutions.
Hello, everyone. I'm going to be covering, like you said, managing SQL queries in complex data environments. So we're going to talk about how companies are striving to store and manage more and more data with these complex environments. The days of different disciplines for different roles are gone, and these multiple disciplines must now work together with the DevOps, thinking of communication and collaboration between these disciplines. The lack of appropriate skill sets can slow down the process, and they're changing and evolving as we're getting into the complex environments. And it's rare to have a company that uses a single platform anymore, so companies and IT teams must adapt. So we're going to cover what some of the complex data environments are, and then we're going to get into how to manage those. So because there are no defined roles, and we're finding that people are crossing over their original personas. Before, you had an application developer and a database administrator, and they were separate, and now the application developer is now managing the application database, and the database developer is now managing the applications, and the database administrator is now managing all these complex environments. But then you also have the outsourcing with using different cloud databases. So we're going to talk about that. And the business analyst, data architect, and data scientists are all dealing with the data and being able to manipulate it. So as these roles are crossing over and merging, being able to see those databases and reverse engineer your database or model the databases is getting more complex. And then these systems administrators are now managing all these different roles and personas that are not as advanced as they used to be, because they have to manage so many things that they're learning more. They have to learn more quickly, and they have to be more versed in what they're doing. So the IT consultants now are coming in and having to figure out all this, and then the IT manager. So an interesting article I thought, and I attached, is how DBAs are changing. Their roles are changing, but they're not going away. So I put the link in here, and it's by DPTA, Database Trends and Applications. And so you can go out and see how DBAs can survive and thrive in a world of agile development with these complex environments changing. There are 8 business processes that for managing a hybrid cloud environment by Database Trends, and I thought we'd go through that or whatever. Determining a hybrid strategy, how it fits in the requirements of the business, that's pretty much already done for you by, when you're making decisions to go to a cloud. And then the number 2 that they consider for the 8 rules is consider the implications of data governance. I'm not going to cover data governance in this presentation, so I put 2 presentations that are done by IDERA staff: understanding SQL Server compliance both in the cloud and on-premise, and business value matrix for data governance. I thought those were interesting if you wanted to go out and check those out. And then enhance the business continuity. That's kind of standard. That'll come to play as you manage these more environments and deciding what you're doing. And then don't outsource your security. That's something I'm not going to cover here either. That's your business process and how your company decides to do it. But I am going to cover ensure the flexibility of the data movement with using these advanced scripts and manipulating your scripts, and embrace the range of tools. I'm going to cover AQUA Data Studio as the tool to here, and expand the scope of service level agreements. That's not going to be covered in this presentation. And then prepare for new skill sets, like I talked about the prior screen, about how the personas are changing and evolving and moving over. I'm going to cover a little bit of that today. So these are the 8 rules for managing hybrid cloud environments by Database Trends. I would recommend you do that for these complex environments. Go and check it out and look at their recommendations for what the 8 business processes are. So let's get into the example of a cloud infrastructure and start a baseline of what we're talking about here. The examples are pretty much you have your peripherals on the outside, and then you have your application stack inside the cloud, and usually you have some type of collaboration, communication. You have your finance or manufacturing or distribution system that you have. You might have Salesforce or something, and all those are either residing on the cloud or in premise. And this one is for the cloud. And then your contact management on what you're doing with that. And then somehow they sit on some type of platform stack, whether it be, you know, a database, a cloud database, a data warehouse, whatever you're doing and managing that. And then you have your infrastructure and how you're getting to it. You're usually connecting in through some web service, your network, or getting into that. And usually you're doing some type of computing based on what you're getting. And so that leads us into what a hybrid infrastructure example is. You have your application layer, like I discussed before. You have your database layer, and somehow they're getting into some connection, and they're getting into the internet and a hosting region of where they're hosting it, and somebody might be managing it, or you might be collecting data scientific information out on the internet. You know, you're running statistics and making your business decisions on how you're moving forward, and so you're connecting that way. You usually have a web layer, and you are managing that. So this is Amazon Web Services hybrid infrastructure. So somehow you need to manage all these scripts and the data and getting the data out, because that's the most important. So these are two examples of a, you know, data structural. So when we talk about the database layer and we talk about the different type of platforms that you're getting in, we talk about relational versus NoSQL platforms, and what does that mean? Relational databases like Oracle or SQL Server, they represent store and tables and rows, and they're based on a branch of algebraic set theory known as relational algebra, and they correlate to one another based on those relationships. Meanwhile, you have the no-relational, the NoSQL databases like MongoDB. Those data are collection in JSON documents and can be stored differently based on how you're getting in. So what does this mean for the database in these complex environments and how we're getting in? SQL is a technology, and it stands for Structured Query Language. And what does it mean? In order to query the database, you have to follow certain rules, right? You have to follow a structure when retrieving large amounts of data, and data is where we're all trying to get to with these complex environments with our scripting, with our SQL. And no structure is unstructured, but it's kind of a little misleading because you still have to have a data architecture, and there are different types of architecture to be considered depending on how you're getting in. And it can provide flexibility to getting and managing very large sets of data because it doesn't have to follow the same discipline as the structured does. So what are the considerations for the database that you've made in these complex environments? One is scalability, right? Your users have to scale a relational database on powerful servers, and the data has to be distributed, handling tables across multiple different servers. So you have to think about these as you're creating your queries on what type of database platforms that you're dealing with. And the NoSQL will automatically spread your data into multiple servers, and the servers can be added or removed from the database layer depending on the complexity of it, right? The complexity of the design of the data needs to fit into tables for SQL, and the database structure will be complex and, again, difficult to handle in large volumes. But the NoSQL database automatically spreads your data into multiple servers without requiring a defined structure, so you can cache that data in system memory, therefore making it faster to retrieve. This is in contrast to the SQL databases where it has to be done using separate infrastructure. So when you're thinking about the considerations for the database and how you get your data out, you're going to start thinking about those as you're creating your scripts. And if you're sticking to standard SQL, then we can help you with that by manipulating it and taking care of some of that for you. To add to the complexity, these platforms have also included SQL in the platform name, but it's just naming conventions. It just pretty much means that it supports structured query languages, and most database platforms support structured query language. They might have a little bit syntax difference, and we'll get into that a little bit later as we start getting into the queries. But pretty much the names that include SQL make it very confusing, but don't let that confuse you. It just means you're tapping into a different platform. So like Postgres, for an example, is an object-related database, and it's released and licensed, thus freeware. As with many open source programs, Postgres is not controlled by any single company, but it has a global community, and it does support SQL. SQLite is an ACID-compliant relational database, and it contains, it's relatively small, smaller than, the programming language, but it's code for SQLite. It's also in the public domain. And then you have the database platforms that's relational, like MySQL, which has more than 6 million installations, and it stands for My Structured Query Language, but it also supports SQL, and it runs on a server providing multi-user access to a number of databases. And then you have the typical standard relational database that started, MySQL, that was run by Microsoft, and that's a relational database management system. So although these have SQL in the naming convention, if you know SQL, you can just get them out. Don't be confused by the naming conventions. So then the naming conventions for the platforms, let's get a baseline. You also have Apache Hive, which is a data warehousing software, and it was built on the top of Apache Hadoop. Hadoop had come out, and it's a faster way for getting to the NoSQL databases, and it's a faster way of querying data and analysis. But it gives like a SQL-like interface to query these data stores in various databases and file systems, because now you're collecting into file systems, not only the where you're housing like you were a typical relational, you need to get to the file systems for the different distributions. So they added to the complexity by providing Hadoop, and then they have the different ways of getting into these different structures. And I'm going to cover a little bit more on how the distributions are worked. So you'll have Amazon EMR, Apache and Cloudera, Hortonworks and MapR, and then Cloudera and Hortonworks, I believe, just merged together. So those disciplines will be working in probably a different way later coming down the road, but you can get into those distributions. So you have all the complexity of your languages, and you have the complexity of your multi-environments for the database programming. And so how are you going to get to these platforms? Well, I've also been asked, what's the difference between a scripting language versus a programming language? Well, all scripting is some form of programming, right? But scripting doesn't require the compiling at the time. So the main goals of your scripting are to automate your certain tasks, to extract the information from a data set, like that's what we mostly care about, is getting the data and making sure it's correct and fast. Less code intensive as compared to traditional programming language, because you're going to do it on the platform at some point in time. You're going to pull the data out, or you're going to store it in a scripting file. And then examples of typical interpreted languages that have to run through something are JavaScript, or we have AQUA scripts in AQUA Data Studio. You have your hypertext preprocessor, which is a widely open source scripting language, scripts that are executed on the server. PHP is mostly used for your web stuff you're trying to get in, and VB script is out there to help you with the Visual Basic script. And then you have Python and R, which were usually used at the beginning for kind of like some scientific notation. Python is like the #1 out there, and R, people are using that as well, but you can use it for basic. So I included a blog out there for database trends, which is using SQL and NoSQL talk databases, single versus multi-plated database use. If you want to read more about that, when we talked about the complex environments and what we're going to use, you can go out and read more about that on the Scaling of Grib's map blog. So the applications of programming language, they typically run inside a parent program like scripts, like we talked about. They're more compatible with integrating code with mathematical models, like we talked about the Python and R. And the languages like Java can be compiled and then used on any platform. So we get in through the Java JDBC for doing some of this multi-platform IDEs, and we're going to cover a lot about that, to how do you get to these multi-platforms, and what are you going to do with your scripts on these multi-platforms as you're moving forward, and how you want to do the best code. But we need to take it down to kind of SQL statements overview. What does it mean? Structured query language is how you pull the data out of these different database platforms, or your NoSQL versus SQL, or any form of how you're pulling data out of a platform database. You're going to want to follow some type of convention, and structured query language is something that has a standard, and that's how you pull data out. So to take it out, you have the 4 particular areas that you care about. You have your DDDL, which is your data definition. You're going to define what you're going to do. you're going to either create, alter, drop, or truncate some type of object inside a database or a data warehouse or whatever it is that you're connecting to manipulate the data. So these are going to be the formats of your SQL scripts and what you're going to do. The DML is you're going to select a particular data from a particular object, like select star from your table name, and you're going to either insert data into that, update, or delete it. So the DML is the data manipulation language that you use. And then your DCL is who's going to get in there, who's going to grant or revoke privileges, who has control of that particular language. So your DCL is your controlling language. And then you have your TCL, which is your transaction control language for commit, rollback, begin your transactions if it's going to be multiple statements, and we'll get into some of that scripting as we move forward. And then rolling back, whether you decide you're not going to commit it to the database, you decide you're just running it for doing stats or whatever you're doing. So when we talk about transaction control language, those are your commits pretty much, and your transactions that you're doing. So these are the 4 basic overview SQL statements that you'll use inside your scripting. You'll use your DDL for create authors, your DML to select what you're doing and inserting or doing something, the manipulation piece, and then the control would be the DCL, and then your transaction control, whether you're going to keep it or not. So this is the basic foundations of a SQL statement in order to do your SQL statements. So the typical life cycle of a SQL query, when you think about doing querying, you want to think about what's going on behind the scenes. You want to go through these steps for each query that you give it, what's actually happening. So when you're creating it, creating your SQL statements, it's going to parse out the particular information that it's trying to do. It's going to optimize that to the best of the ability based on what you gave it. If you have variables pulling data back or whatever you're doing, it's going to try to optimize it based on what engine you have or what platform you have. And then it's going to execute. It's either going to commit, roll back, or it's going to run that and give you a return set. And you can elect to save it to the database depending on what you're doing. So you're parsing, optimizing, and executing that type of query. When you're thinking about building all these queries and these strips, you want to think about most of all the optimization part, because you want it to be fast. You don't want to take tons and tons of times to be able to pull out this data or hours moving forward. And if you do that, then you're going to want to schedule it off when you move it to a different. So in the database platform world, and we talk about these complex environments and running these SQL scripts, we also talk about syntax, right? Because most of it for SQL statements is there's some type of procedural language that is used by those particular platforms. Like for Oracle, it's PL SQL. It's this proprietary procedural languages for getting the data out. And then you have your TL SQL, which is the procedural language used for Microsoft SQL Server. And then you have a PLPG SQL, which is a procedural language used by Postgres. And pretty much everybody uses the embedded structured query language that I told you. It's just sometimes the syntax is a little different and will allow you to control that. So these are the procedures that you'll run on a particular database for getting data out and for coding for the database developer who's going to do the coding. So sometimes when you're assigned a particular project and you're not exactly sure, you're learning, you're new to the languages, sometimes it's just the syntax and you need to look up the particular syntax for that database discipline. So to create a table in PL SQL, you can see the naming conventions are here. You create the table name, the object name, because you're going to create that table and you're going to define what data types and all that you want to do. And so the structure here you can see is different. When you create it in SQL Server, in T-SQL, you create the table name and it just looks a little bit different running here. And then the same thing for these examples for Postgres. Same thing, it's just different formatting of what you want to do moving forward and where you're pulling the data from. So not only do you have to keep in mind of what database platform you're using, you need to keep in mind where it's housed, whether it's on-premise or the SQL. You also need to think about syntax and how you're running it. And you want to think about the way it's going to parse that information out because you want it to be quick. So there's a lot of things to think about when you're working about these complex environments, and I'm going to tell you how to help with that moving forward. As you're new to it or as you're getting more advanced, you're going to want to keep these things in mind. So this should give us a baseline of how we're moving forward and what we're doing it. So when we talk about getting the data out, we're now getting into the queries, and more queries, and how do we want to do that? Well, there are a few differences between the two dialects, like I told you. If you stay with the structured query language, you don't have to work about it, but like for Google BigQuery, for instance, their count distinct returns an approximate count, and their standard, you can select when you're setting up the database which particular version, it provides an exact count. So you want to keep in mind, you try to stick to standard if you can, and then you don't have to think about, when you're manipulating for other database platforms, but we'll help you with that moving forward. And then what type of queries are you going to run? Are you going to run a single query? Or are you going to need to run a multi-database instance query for, a tapping? And so when you think about standardizations in your company, how do you want these queries to look? Are you going to have the quotes, with backslashes, or how are you going to do that if you want to standardize in a certain approach for these different database platforms? Because then you only have to write the queries one way moving forward, and that's going to help. So when you have these scripts and you run multiple queries to be saved, you can schedule them and run them later, because we talked about scripting being a programming language somewhat, and it just doesn't have to be compiled, but it allows you to do multiple things with these database queries and pulling the data out. So how do we help you with that? AQUA Data Studio is the product I'm going to show you, one of the tools that we use at IDERA, and we have a lot of customers are using. And it's a universal database IDE and a visual analytics tool, and it allows you to work with data databases. And so it allows you to develop and manage these databases, access, import, export, and visually analyze your data. And it supports over 30 database platforms working in all major operating systems, whether it be Windows, Mac, or Linux. And it supports, like we talked about, the relational, NoSQL, and cloud databases and data warehousing, so that you don't have to think about the different disciplines because you're working with one IDE. So it makes that data easily workable, and we're going to get into how you manipulate those scripts all from within one IDE, no matter what platform that you're talking about. So here's the database platforms that it supports. I talked about the relational databases. I talked about getting into Hadoop with the different distributions and how do you get into Apache Hive on top of that for Impala and Spark connectors. And how you're going to want to get through the different distributions, managing that to add to the complexity. You also have the relational databases, Oracle SQL Server DB2. You also have Snowflake for your data warehousing. You have SQLite for your relational or partial. And then you have, AWS and some information for moving forward. So these are all the database platforms that it has this. Now, AQUA Data Studio gets to the complexity of the NoSQL and the distributions using the Java JDBCs. I told you we get in through the Java JDBCs, and it attaches to the servers, whether it be Impala, Spark, or Hive. Through the driver connections, we supply all the drivers, and it allows you to get to those meta stores, whether you're storing them on file systems or job clients, and so that it looks like it's all one IDE, depending on how you're getting into that Hadoop cluster. It allows you to manipulate whether you're doing the Metastore or you're doing the Hadoop cluster by getting to all those. So this is pretty much an overview of the complexity of the NoSQL and its distributions and how you're tapping in, doing that. And what does it support? So its primary features are going to be, you're going to register the server or the database. It's going to look the same for each of your NoSQL or SQL platforms, so that it helps with your scripting. It builds when you connect into AQUA Data Server, it builds this navigation tree. So as you can see, this navigation tree, I have MySQL, I have Oracle, I have Postgres, I have, you know, all these different database, Sybase that I'm getting into, all these database platforms, and I built this navigation tree by my connection files. Now I can share those connection files with anybody at my company so that if we get a new database, I can share that. They just have to put in their passwords because we don't give the passwords via the connections, but they're all stored locally in their connection file for you to get in. So what does it have? It has a query analyzer for doing your SQL editors, and I'm going to get more into that because we're going to start showing some queries and what we can do with those. And then it allows me to have a query builder for building those SQL queries if I'm not very familiar with building the syntax myself. As I discussed, the syntax is a little confusing as you're learning, and so you want to help with that. So the query builder will help build that by using drag drop objects to be able to build that for me. And then we have a table editor for you doing some manipulation of your table. You can save the results in scripting files, so you can use those for AQUA scripts. You can use them, you know, be able to manipulate them, and then the scripting editor will save it in HTML, XML, text, or Java, and then it does the auto completion and stuff for you, so you don't have to think about that. We also offer the visual analytics. I'm not going to cover that except for a brief overview, but if you're doing any type of analytics for the data scientists or anybody who's a data analyst and needs to see a dashboard of their objects, we also offer that. And then we offer tools for import, export data and DDL, like I talked about, the manipulation of the data. You're going to need that for bringing in Excel spreadsheets and being able to import those into the database and manipulate those for creating your scripts. And so we do offer that. And then you can do schema and data and file comparison. You can compare those files. If your boss sends you one Excel 1 week, you import it in, and he goes, oh, by the way, every week I'm going to have a new updated Excel spreadsheet for you. Then you can do comparison against those, or you can import and run it over. We also offer ER modeler for reverse engineering these platforms. So if you're new to a particular database, like now they're going to a data warehouse and they have Snowflake, we allow you to reverse engineer those, and based on the metadata and how it's working, we can infer relationships for you. If you want to see how everything ties together or are just not familiar with it, then you can use the ER modeler for that. And then your database administration tools for manipulating the data. I talked about how the everybody's crossing over, your personas are crossing over, and so you might be doing some database administration whereas you were a developer before, so you're kind of stepping on each other's toes, and you need to see who has locks on that particular table, because one developer can't get in and you were never a DBA before, but you want to see who's locking that particular person out. You can do that with some of the database administration tools that we have. So when you're building those scripts and it's not running or it's coming back as an error, you can see who has that table and maybe schedule it offline or decide what you want to do with it. So these are the primary features that AQUA Data Studio covers, and we're going to start drilling into how do we get into all these different servers and manipulate them. So this is the tree that the connection files I was telling you about builds over here, and as you can see on the left hand side, I have connection files to Amazon, Postgres, DB2. I also have some Excel files that I've read in. My boss is Frank, and he sent me the file, and so I'm reading his in. I created a project with it, so I'm managing those particular files. This is the connection screen. So it's a very powerful tool for these database connections. Mostly we do the native connectivities, but we do allow you to do some ODBC connections and some non-native. If you're not getting in, we have generics here as well, but most of these are native, so it's faster for creating your queries and doing all that. And then you set up your connection name. You can also specify the tab color, which I find very informative for my scripts moving forward, and I'm going to show you in the next screen, is that for development, I might have blue for development and then green when it passes development or it goes to test. Then I have it set as green, but when I want to run it on the database, I set it as red, because I know that if I see that red, it's a production database, and if I commit that to production, I know I'm committing on the fly, so I usually set that color as red. That's just the way I like to work, but you can specify these however you see naming. And then on your connection screen, you can filter what you want to see. You can only see particular objects or namings or servers that you want to by filtering when you connect to a particular, like if I connect to Google BigQuery and I only want to see certain instances, I can do that by selecting the filter. And I could do advanced. I can run a script at the time I connect, and I can get connected to doing that. And then I can specify the drivers that I want to use if I don't want to use the particular native drivers, and then who has permissions on that particular instance. I can manipulate that. And then the scripting of where the script is located and how I run it when I connect to the particular database. So it can get really advanced really quick based on how you're connecting as you're drilling into these different options. And then fluid shell, if I'm running something that I need to, it needs to be more advanced, that's for coding, I can do it with fluid shell as well. And then I can monitor the connections if it's up or down, and see exactly how I'm connecting in. As you will see, when I change these database connection files, this screen looks the same. It just changes the authentication and the credentials based on how you're getting in to that particular database. So how do we query the data? I talked about the different colors of my production, my test, and what I'm doing with these particular databases, but this is the SQL editor. So I can see my connections here, and I can specify my queries. I can type in a select statement right from within here, change the database instance, and run it. I can also automate these scripts. I can do some automation, and I can say infer and do type ahead syntax. Like if I'm doing select star from customers dot, and I'm not sure of the object names, it'll automatically pop up the object names, and then I can automate that running forward, and I can have some type ahead syntax and do that. We do a lot of automation with the scripting, and we go from within the product from here. I'm going to get more advanced as we go through. So when I talked about the complexity of the databases and you're dealing with different syntax, you want to keep that in mind. But if we standardize on particular syntax, I can set up my query analyzer or my SQL editor to say, use this across all my databases. I can set up my comments to look a certain way. I can specify my statement separators to be Go. I can specify the quote identifiers that I want to use, and I can specify it to qualify the object with the schema name if I want. So as we're standardizing and making sure we get into all these complex environments, how do I help cut down with having to figure out how to code for the different discipline if I'm running a script for the different database? Well, you don't want to have to think about that. So you can do the query analyzer by selecting it to be across all your databases, or you can do scripts based on the particular database platform that you're running and specify how you want that to look. And I'm going to cover that and show you as we get into that. So some of those conventions you're going to want to figure out with your developers or whoever's running scripts or your DBAs or your analysts, whoever is doing this from a naming convention. You can either take the defaults that come with that platform, or you can specify how you want these to look and feel. And it's it helps cut down the time on running these scripts across multiple different environments in half. So we had talked about the SQL statements and the basics of the SQL statements. In AQUA Data Studio, the schema script generator will allow you to manipulate the DDL, make it standardized. And then we have a scripting window. So if I'm particular on an object in that tree and it's collected on a table, like a customer table, I can right click and say script this object to window as a select statement, and it'll automatically put the select statement in there. I don't have to think about coding it. It takes on the structure that I had already specified in my setup of use comments this way and all that. And then I can generate an AQUA script. It's a scripting language like JavaScript, and it gets pretty advanced and what I'm going to do with these scripts moving forward. And I'm going to show you an example of how you can set up AQUA scripts in here to be able to run those offline and to be able to manipulate that moving forward. So how do I query the data with AQUA Data Studio? So I was telling you that you could query the data. You can execute and run your queries from within here, like select from doctors. As you can see, I have a select statement up here, and then I have select from invoices, and I have 2 result sets from within here. I can do multiple things with these result sets running forward. I can edit the table data editor. Like I said, we have the scripting editor for HTML, XML, text, or Java, depending on your particular discipline and how you want to do it. I can show the text history, which is really awesome. I can save up to my history. So let's say I ran this SQL script and I go, oh, I ran a SQL script a week ago, but I'm not exactly sure what the return was. I can go into the SQL history and see all the SQL scripts that I ran on different instances, which is nice. It'll store 100 to me, 100 of those definitions. So I could say, oh man, now I can look at what I ran last week. I knew I ran it on an instance, but I wasn't sure if I ran it on production or test. What did I do with it? And so I can actually connect and show the history, what I did. I could show the execution plan. So if I wanted to see the statistics or the execution, the route the database takes, I could also do that as well with the SQL editor. So as you can see, I can click on these multi-servers and I can get the result set or see what I did from here. I could change the connection of this on the fly by just reconnecting and seeing what I ran from within there by running the table data editor by doing the connection based on where I'm connecting. So I can switch my connections here. I can load 10 of these moving forward if I wanted to, and then I could do it from within there. Now, if I am running a debugger, like let's say I have Oracle, and Oracle has PL/SQL, I've talked about the procedure code. I can actually debug my procedure editor from within here. I can step into that procedure, make sure that all my DML and everything is correct and how I'm running it, and it'll see the different disciplines. So when you build this tree right here, it actually sees what I'm on. So this is an object type of a stored procedure. When I right click on that object type, it's going to show me what's available for that particular discipline of that object. So this is an object of a PL/SQL stored procedure, and I can debug it. If I clicked on a table from within here and I right clicked, it would see that I have a table. So it'd say, what do you want to do with that table? I could script it as a create statement, a drop statement. I can do an alter on that particular table, and it'll do it based on the discipline. If I clicked on the instance here in healthcare, it would say, what do you want to do? Do you want to drop this instance? Do you want to, what are you doing from the right click menu? So it's very powerful on the object sensitivity of being able to see what you're doing, but also up here too for writing your queries. I could go to the query window here and I could populate it from within here, but I don't have to run it in here, and I can manipulate that way. So you could either do it by the menu or you can control what you're doing based on the object type. So building your scripts, it gives you an advanced way of doing it by populating it into the query analyzer window and being able to start that script from there. So scripts and more scripts. I talked about how you manage the multiples and if you ran a single script. Well, you can also right click and say script object to window as create. I could select multiple objects from within here, and it'll either generate it for me or generate a template script if I want to select from orders, employee, address type, and person all at once. It'll multi-select those objects into the query window, and then I can run them from within there. So it also does it that way. The schema script generator is very powerful. Like I said, we have tools that come with the schema script generator, and I could run the schema script generator to manipulate that script or generate it for me right off the fly based on this instance, select everything from this particular database, and then I can save it and manipulate it later if I wanted to. So it's very options. So the options are pretty much available for doing the generator, and you can specify some specific objects for your particular scripts. Like I said, you're probably going to want to standardize on some way of doing your scripts, but also know that you have different database platforms that you're dealing with when you're in these complex environments. So you can specify your scripting format here, and then it'll take on the discipline that you set in your options to go, and I could click on what I want to see for this particular script. I can set a network drive if we're sharing our scripts and we're doing that, so I can specify where I want to store this, or if I want to keep it local, I could do that, and how I wanted to do it. The platform will be here, and of course the encoding for that particular database platform, if I wanted to change it, I could do it from within here. So it's a very powerful way of generating these scripts from within here. Here's an example. I've talked about the DDL for create, alter, and drops. This is what you get. It's going to alter that particular, it's going to create the table from that select statement, and here's the type of example that you're going to get from that. Again, I can change all these if I wanted to and specify quotes to look a certain way or to manipulate, you know, based on the disciplines of my particular. So the scripting option allows different formatting too. You also have your code formatting. So if you don't want to see, you have this script happens to have, you know, create tables, tons of create tables in between. I've seen scripts huge and I've seen them small. It just depends on what you like to work. I could also do the code folding. So if I didn't want to see, you know, I could click on this ... and it's going to show me the create table. But if I didn't want to see that because I want to run fast on my scripts and I only need to get to a certain part, I can also search within the scripts and do filters from within the scripts and see only what I want to see. But code folding is also available for manipulating these scripts as well. And then I have the multi-server query, meaning same vendor. I talked about how some people, when they're learning how to do queries, they're not familiar with it. So you could go to the query analyzer window and you could have your query builder for you. You could pop it into the query analyzer, which is your SQL editor, or you could build the query with your query builder, and this will help you. So as you can see, I'm connected to two different databases, a master and right here, and I have two instances of this databases, and here's all my tables, and I'm going to drag those tables over here. And it's going to infer the relationships because this is a relational database for me, and it's going to build the SQL and the joins for me here if I'm not familiar with it. Now, if I didn't want to infer this relationship, I can take that off. I can specify a where statement, and then this is building the queries for me. I can save this SQL off and embed it within my queries, or I can have it save it to a file and manipulate it. I can look at the grid of what I'm going to get by running it. I have some statements up here, and I can see it's actually what I get from that particular database from running it forward. So now as I'm starting to get with more and more scripts and I'm starting to manipulate these more scripts and getting more advanced, I'm going to use a project window from within AQUA Data Studio. There's a projects tab in there, and they're comprised of AQUA scripts, which I told you are advanced scripting, and the server connections are built in, and then I have user files that I want to use from within there. So it's kind of a self-contained programming language unit that allows me to create the AQUA scripts, but it also allows me to organize and manage those scripts. And so I can specify in a certain set of database servers that I want to use to get more advanced. So once I create the project and it's completed, I can export and share these files with others. I can host it on a networking server for the complex environments, and I can specify to do it. So AQUA Data Studio does come with some advanced scripting, and I'm going to show you what that is. For 6 delivered, pretty much. We create and have an email Excel sample file because customers are always using that. Usually their boss is wanting them to, you know, import data like I talked about as a business case for Excel files, and then they bring it in and somehow they need to do that once a week or once a day, and so they're constantly need to do that. There's also database schema and data exporter as well, because I'm exporting data out. I've received a new database platform. I'm not exactly sure what that data looks like, so now I want to export the schema to take a look at the metadata. I want to look at how it looks, and then I want to view the data and be able to manipulate it. So once I do that, I can get a template for doing that. I might want to file transfer and remote command execution because I don't want to run it offline, and I'm more advanced in using Linux, or I want to do something with it as I get more advanced with my scripts. As for the, you know, people who are more advanced, then you might want to do that and be able to remote connect into that particular database depending on, you don't want to connect through a server somewhere or a network connection. You have tunnels set up and you might want to do it that way. You also have multi-server script execution like I talked about. You want to do, those are on the same instances as the template that we give you. We don't do it from like server to server and translate. It's not a transformation tool. We don't do any of that. And then random table and data generators. So if you want to do some random tests and you need to do that, we give you the template for doing that as you're testing. I talked about you might not want to execute that particular SQL script in your production database. You might want to run some test data first and see what the load's going to be before you do that. So you might want to do that. And then compare those files. Do some type of schema compare as you get closer to testing it and be able to see that. So we deliver these AQUA scripts. Here's an example of what one looks like. I set it up as the one I used was a template for emailing an Excel file because that's one that's mostly used. And then this is the template that we deliver. As you can see, we put in the input parameters based on the AQUA Open API that we have, and it takes in from the GUI. So right here you can see Lisa Server 2016. I had put all this information into the GUI, and then once it did is it set the template up for me. It's the healthcare database. It's going to select from my doctor's table. It's going to use it locally, or I could set a network drive if I wanted to, and it's going to email the Excel file that I had from within there to the recipient that I set for it to do. So this is pretty much an example of the scripting, and then it fills in all these parameters for you, and it'll do some, some error handling and stuff if you specify it for to do that as you get more advanced in what you want to do. So when I set up my project directory structure, this is what I created. I created a project and I said it's going to be an AQUA script. These are the servers that I'm connected to. I did DB2. I created the AQUA script, and then this was the Excel file that it created for me. And these automatic folders are automatically generated for you. So it has AQUA script, servers, user files, and then you specify where you want these to go. So when you set up the servers and you connect it to your databases, if you click on this tab, that's your servers and all your connections. Then you can also do it by project. So I can control it this way if I like to work that way. So it sets up these folders, create an email sive, database schema and data exporter. Here's the scripts, query analyzer, demo, random table and data generator, and then schema compares for doing those particular templates. So as you get more advanced, it can get more advanced with you. Tools to help manage all these environments. Like I said, we have compare tools. These are all the tools that come delivered with AQUA Data Studio, schema, data, and doing file compare and all the manipulation from within there. We also have integration in with MapR. I talked about you doing some statistical data. This is integrated in for visual analytics, and it does a reserve connection and it builds some of that scripting for you. Not everybody's going to be familiar with it, but that's what you have. So for people using the visual analytics, this is just kind of an example of a dashboard. I have 3 sets that I specified: profit by product category at the top, profit by geo, and profit by state. I ran these and then I created a dashboard just from the results set. So I went into the SQL editor, I selected my profit by product category table, I ran it, and then I built these dashboards within less than 5 minutes, all by selecting from the results set that I returned from those particular data. So a summary of AQUA Data Studio and how you manage some of these complex environments and these scripts is, we talked about the basic scripts and the scripting editors that you have for HTML, XML, text, and Java. You also have the auto completion to help you with those, moving forward. And then you have the different disciplines for the different databases where you really don't care about what database platform you're on, because you standardize your scripting via the options window, and so your scripts are going to have the same coding that you're going to have, and they're going to take on the discipline of whatever comments and whatever you want to do from that moving forward. And then you have some database administration to see how those scripts are running and how you manage those different environments moving forward with that and doing all this. So pretty much that's the summary of of running multiple scripts and being able to manipulate your scripts in these complex environments and being able to manage all of it. So if you guys have any questions, why don't we open it up to some questions?
Great, thank you so much, Lisa. We do have a few questions that have come in. The first question that we have is, how does AQUA Data Studio help me migrate to cloud database?
Well, it keeps all your scripts like I talked about. There's a lot of different ways that helps you with this process, but the directory structure for managing your projects, you can create all your projects and manage them and keep them out on a network drive somewhere and being able to work in sync. So it keeps all your scripts in one place. It allows you also to compare your objects. So once you've connected to your particular database platform, depending on where it is, if it's data warehouse, it's NoSQL or SQL, it doesn't matter. It allows you to keep those objects all there and compare those to see if there are any additions. It also allows you to feed in your database if you're using to import particular code. If you need to do that, it manages that scripting. And also one thing that I think is very underrated, and I talked a little bit about it, is the SQL history. Keeping the SQL history of what you did over a period of time and being able to compare both of those SQL, I ran it last week and now I'm running it, I can see what I'm getting from those result sets, which is really nice to see. Or if I just am not all there today, haven't had enough coffee, and I need to see, what I ran last week, then I could go back in and do it from there. I hope that answered your question.
Great. The next question that we have is, does AQUA Data Studio evaluate a query's performance?
Yes, you can do query performance. There's a lot of different ways because we're a database management tool and a developer tool. We actually cross the lines of doing that, so we allow you to do a lot of that. You can use the visual explain plan, which I talked about, which tells you the route that the database is taking to be able to get to that particular SQL statement or the DDL. So you can see how the route is taking, and then you can work on that query to make it more performance. You also have the session manager for users and roles. If people are stepping on each other's toes and permissions, you can also see it from that way as well. And then again, you have the SQL history that I talked about. You can run baselines if you wanted to and see, I ran it last week, what did I get from that query? Now I ran it this week. I did some tweaks on the database where my DBA said he did some tweaks. What am I actually getting from that SQL? So there's some things you can do with it as well.
Great. We do currently only have one more question, so audience, if you do have any more questions, please post them into the questions panel. The last question that we currently have is, does AQUA Data Studio have a way for developers, when coding, to keep different versions?
Yes, we integrate in with major source controls like Git, CVS, and Perforce, and we allow you to do that. You can also use the directory structure, the project that I have created here, and you could see the different versions if you kept it on a network driving that way. But you probably want to use some type of source control. I'm sure your company probably has some, and you want to make sure that you integrate in with that to be able to control and manage your scripts that way.
Perfect, Lisa. That is all the questions that we have. Is there anything you'd like to add before we close things out?
No, you can go out to IDERA's website or go to www.aquafold.com and look at the product, and hopefully we can help you manage these complex environments with your scripts. Thank you so much for listening today.
Great. And with that, I'd like to thank you, Lisa, for a great presentation today. I'd also like to thank today's sponsor, IDERA, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.
Great, thank you.